Okay, so this is on algebra. The first little thing I'm going to teach you is simplifying. And there are 4 key things I think you need to remember when you are simplifying or collecting like terms. Okay, so the first thing we've got A plus A. Okay, these two here are what we call terms. Okay, so we have to try and group them together to try and simplify the sum, because this isn't in its simplest form. What we can do, because these two are the same term, they're both A's, we can collect them together. So this would actually become this, okay? And this is classed as simpler. This form is much simpler. Right. So when you're collecting like terms, it might be that you have numbers involved already, okay? And they're paired together like this. This is saying 3 lots of A, and then you might have 2 lots of A. In this circumstance, okay, it's like just adding 3 and 2. You've got 1, 2, 3 A's plus the 4, 5 A's. So that would be written like this. When you're adding them together though, I think it's important to try and remember that there may be some negatives there. So being very aware of what you're actually adding or taking away. So if you had something like this, 3A plus 2A minus 4A, okay? The first thing I like to do is to collect the positives together and the negatives together. So my positive numbers are, definitely got this one here, and we've also got this one here. If there's nothing in front of a term or a number, it's positive unless there's a negative there. Okay, so 3A and 2A, like we did earlier, is 5A, and we've still got the negative minus 4A. Now what we have to do, it's like asking yourself, if you had 5 apples and you take away 4 apples, you'd be left with 1 apple. When you've got 1A, an A on its own, like this, means exactly the same thing, okay? So you can either put that answer or that answer. They're both right. So that was the first thing to think about, your positives and negatives. The second one is paired letters. Sometimes you might have something like this, a G and a H. When they're next to each other like this, they're actually multiplying each other. It's saying G lots of H, and you can't separate them. Even when I say put that there, we can't pair those two together because that is already connected with the H, and this doesn't have a H. If we did this though, those two terms are exactly the same. They're both GH, GH. So we can add them together. And when we do, it's like saying 2 lots of GH. The 2 letters stay together. They're not broken apart. So far what we've said is you have to think about negatives and positives and paired letters. The third thing you need to think about is capital letters, like B and B. That's a capital, this is lowercase. The difference is that they're different terms. If I put a plus in there, there's actually nothing I can do. This is a different term to that one. I can't add them together. So we've said 1, positives and negatives, 2, capital letters, and third, capital letters of the same letter can't be added to its lowercase. The fourth thing and the last thing you have to think about when collecting like terms is your letters with powers. And I'm not talking about flying or telekinesis. All I'm talking about is indices, okay? This little power here. This little number tells me how many times this letter is multiplying itself. Just like with any number, like with 7 squared, we'd do 7 times 7, which is 49. This is telling me this is x times x, okay? Or x next to each other. But that's the way it's written. You wouldn't write it like that. It'd be written like this. If you had x squared plus x, we can't add those two together. Again, the different terms. That's an x squared, that is an x. Unless that was an x squared, that is the only time we can add them together. In which case it would be 2 lots of x squared. So the 4 things to remember about collecting like terms is 1, your negatives and positives. 2, your paired letters. 3, your capital letters. And 4, whether it has powers or not. And these all make a difference, and you need to check for them. Collecting like terms is simple, easy, but if you forget one of these, it's an easy mistake to do as well, and you can lose marks. Okay, I'm just going to carry on with this, okay, and go on to multiplying algebra. So, if you had, say, a number times a letter, okay? We don't know what the value of the f is, okay? We're not trying to solve here, we are just multiplying them together, okay? And the only thing we can do is take out the times and push them together. This means exactly the same as that. It's 4 lots of f, okay? So if you were given a sum like this, if it was, say, 2f times 3f, I like to think about what these actually mean and try and break them down, okay? So if I had 2f, that's the same as 2 times f, I'm still timesing, and 3f is the same as 3 times f, okay? So I'm going to start with the numbers first. 2 times 3 gives me 6, okay, and then I can cross them off. I'm then going to times my f and f. If I've got an f times f, like I said earlier, we count how many times it's timesing itself. It's timesing itself once, twice. 6f squared. Okay, it doesn't stop there with the squareds either. It can carry on. If you had p times p times p times p times p, it's much more than squared. You have to count again how many times it's multiplying itself. You have 1, 2, 3, 4, 5. It's multiplying itself 5 times. So I write my p and the power of 5 in the top corner. This tells me exactly the same as that. Okay, I'm going to give you another example now, very similar to the ones I've given you before. If I had something like this, hi times hi, okay? I'm going to break that down again. It's the easiest way I find. My h and my I next to each other mean multiply. So I'll split those up into h times I. Means exactly the same thing. And multiplied by h times I. So, I like to do things in alphabetical order, and that's the way they tend to like to see things on your exam papers as well. So h comes before I. So, h times h. It's times itself once, twice. So we've got h squared. I times I. It times itself once, twice. I squared. And they go together, they're still pushed together, but this tells me that that letter is squared and that letter is squared. If it looked like this, h I squared, this is telling me that only the I is squared. The power has to be next to the letter, okay? This tells me that it's h times I, which is different to that, okay? When you're dividing, again, I like to try and break things down into like what they're actually made up of. So if I had 4p divided by 2p, for instance. I'm going to change that into almost like a fraction. So I've got 4 times p over 2 times p. So let's start with my numbers. My 2 is dividing my 4. So if my 2 divides my 4, I'd be left with 2 on top. My p divided my p, okay? You have to remember that they are exactly the same. If you have exactly the same number, like 7 divided by 7, that would equal 1. And it's the same with the letters as well. They're going to fit into each other once. So we get rid of that, and we'd have 1 at the top, left over. 2 times 1 is just 2. So 4p divided by 2p is simplified to 2. These again don't tell me the actual value of the p, but they're just being simplified. It's not actually solving, it's all about simplifying, making things look easier. Something I maybe missed out from before with multiplying, if I had p to the power 4 times p to the power 3, what you can do, rather than breaking it down, it's very simple, is you actually add the two powers together. So this would actually become p to the power 4 plus 3, which equals p to the power 7. That was important to mention because if you had p to the power 4 divided by p to the power 3, it's the opposite. Rather than adding, you take away. So you'd have p to the power 4, take away the 3, which would leave you with p to the power 1 or just p. And if you break that down, like we did earlier, so if you had p times p times p times p over p times p times p, you can see straight away that these here, these p's, are going to cancel each other out, and you'd just be left with the 1p. Okay, the next little thing we're looking at is MOB, or multiplying out brackets. Okay, so if you had, say, like 3, and then you've got brackets x plus y, everything that's inside the brackets is being multiplied by the number that is touching the brackets outside. It has to be touching. If there is a gap in between, say like 3 plus x plus y, the 3 isn't doing anything to that. It has to be next to it. There's an invisible multiplying there. Because it's actually multiplying, it's multiplying everything inside the brackets, and we multiply them separately, okay? So we've got to multiply that by 3 and that by 3. So the first one, let's break it down. You'd have 3 times x. There's nothing we can do there because we don't know the value of that x. We just have to push them together. 3x. We've got a positive, okay? Careful. If it's a negative, then you would have a negative here. Unless, if that was a negative. Got some work to do on your negatives and positives. You should always be thinking about those. So, 3 times y. I'd end up with 3y. And the reverse of this, if you were to work backwards and put the numbers in the brackets, that's what we call factorising. Taking out that factor of 3 that is common in both of these terms and putting it outside of the brackets. So just a little bit of a thought on those negatives and positives. If I have a positive times a positive, it's positive. If I have a negative times a negative, it's also positive. So if you can remember that if the positives and negatives are the same, so negative, negative, positive, positive, then any answer you get, if it's multiplying or if they're next to each other, is positive. However, if they're opposite, like this, then they cancel down to a negative, okay? So let me show you an example. 3 plus minus 2, okay? The positive and negative, they're different, they're not the same, so it cancels down to a negative. You've just got 3 minus 2, which would give you 1, okay? Another example, negative 3 times negative 2. We've got two negatives. Two negatives give me a positive. So any answer I get, I know is going to be positive. 3 times 2 is 6. It's positive 6. And I don't actually need a negative there. Just get rid of that. So just as a last little example for you to see, if I had minus 2 x plus 2. Okay, again, that's going to multiply that, and it's also going to multiply that term. So I'm going to have minus 2 times, and remember, if there's nothing in front of it, it's positive x, okay? A negative and a positive together, my answer will be negative. 2 times x, I can just put 2x, negative 2x. The next one, I've got minus 2 times positive 2. Again, a negative and a positive will give me a negative answer. 2 times 2 is 4. That is my answer. Minus 2x minus 4. If I'm actually factorising, so the idea of this is to put the brackets back in the equation, I'd have to start with something like this. 6x plus 6y. Okay, I have to think about the factors that are present in each of these terms. What makes up my 6x and what makes up my 6y? Now it might be straightforward here. The common factor we can see straight away. It's not the letter, it's the number. Both have a 6. So I can take that out. And it's like the reverse, okay? My 6 is going to go, say, down here. To find out what I put in my brackets, I need to divide, okay? This is the absolute reverse, the absolute opposite of multiplying out the bracket. This time, rather than timesing by the factor, I'm dividing. So I've got to do 6x divided by 6. 6 divided by 6 would leave me 1x. Again, 6y divided by 6. The two 6's can divide each other. 6 divided by 6 is 1y. And there you have it. Sometimes things can get a little bit more complicated though. You might have, say, 5x squared, and then maybe a plus 25x, okay? With this one, you could have two factors, and it's your job to try and pick out both of them, not just one. So with my 5x squared, what makes that up? Let's have a think. I've got a 5, an x, or an x squared. There's no point taking out a factor of 1 because it wouldn't make a difference. The 25x. That can be made with 5, 25, or x. Okay? So I'm looking for common things. I've got my 5's. Not x squared, but I have got an x. Okay? So I'm going to take out a factor of 5x. So there you have it. There's my 5x and my brackets ready. Again, complete opposite, I'm going to divide. So 5x squared divided by 5x. I might change this for a fraction version just so you can see. Okay, so for both of those, I've broken them down into what makes them. If I did 5 times x, I get 5x squared, okay? And again, if I do 25 times x, I get 25x. I'm going to divide each of these, okay? And I can cancel them down. My 5 divided by 5 would leave me with just 1. If I get rid of x and x, That would leave me with 1 as well. 1 times x times 1 is just an x. Again with this one, my 25 divided by 5, that would leave me with 5, okay? My x's cancel out, they can fit in each other once. 5 times 1 leaves me with 5. You might be able to see things straight away, you might not need to show this working out, okay? But if you do, it's a really good way, okay, of just like cancelling down, and you can see what you've got rid of and what you've kept. Okay, so this tutorial's already got quite long, so for solving and substitution, you can find that on another tutorial. You have your own worksheets to work through. You can look back at this, pause it, and recap things whenever you want. It's here on YouTube. Try the questions, bring them in, and I'll mark them. Thank you.